All right, guys. So what we're going over today, 7.32 is division, dividing two polynomial expressions. Now, dividing two polynomial expressions is not really going to be any different than what we did Friday with multiplying. The only main difference is our first step, because when we divide two fractions, we change it from division to multiplication and flip the second. That's really going to be the only difference. So we take two rational expressions, we change it from division to multiplication, and flip the second rational expression. And then we do the exact same thing, we multiply it out. So if we look at this first one here, taking the quotient of 7x over 2x minus 10 and x squared minus 6x over x squared minus 11x plus 30, the first thing we can do is rewrite out the first rational expression, 7x over 2x minus 10. We change it from division to multiplication, and then we flip the second. So our numerator is now the x squared minus 11x plus 30, and the denominator is now x squared minus 6x. Now after this, the rest of this is going to be the exact same as what we did Friday. So before we multiply them together, we need to factor them. Before we multiply them together, we'll need to factor them. Now out of these four, 7x doesn't factor. It's as simplified as it gets. So we have 7x. Now the next one that's probably going to be easiest to factor is going to be the 2x minus 10. Because between 2x and 10, they both have a greatest common factor of 2. And we could factor it out. If we factor 2 out of 2x, we get x. And if we factor a 2 out of 10, we have 5. Now the other one that we can factor is the x squared minus 6x. X squared minus 6x has a greatest common factor of x. They both have an x term, so we can factor it out. And if we factor the x out of x squared, we get x minus 6. Because if we take the x away from 6x, all we have left is the 6. Any questions on this so far? Now the next thing and last one we need to factor is the x squared minus 11x plus 30. Since there's no greatest common factor, we can go on to our two sets of parentheses with 3 spaces. Since the third term is positive, our signs are the same and they match the sign of the middle term, which is negative. So we'll have negative and negative. Factors of the first term, x squared, are going to be x and x. Now our factors of 30 are 1 and 30, 2 and 10, not 2 and 10, 2 and 15, 6 and 5, yes. Yeah. Okay. There we go. Took it a minute. So 2 and 15, 3 and 10, 6 and 5. So we can do 6 and 5 first, and if we check this, x times negative 5 is negative 5x. Negative 6 times x is negative 6x, which does indeed give us negative 11x. So that is the middle term that we need to have. Now that we have those factored completely, we can multiply them together. Now, we can go on and connect the 2 and simplify this way, or we can rewrite it as 1. So we'd have 7x times x minus 6 times x minus 5 over 2 times x minus 5 times x minus 6. So we can rewrite it as 1 and kind of move them all together, or we can connect the 2. Now our terms that'll factor out, that'll simplify, will be the single x and single x, because x divided by x is 1. We can also cancel out the x minus 5 and x minus 5. And lastly, we can cancel out the x minus 6 and x minus 6. So what are we left with? And that right there is the final answer, 7/2. Questions on this here? Yeah, funny enough, everything canceled out except for our two numbers. Any questions over anything we've done so far? Now, the restrictions. We talked about the restrictions on Friday with multiplication with 7, 3, 1 on what x cannot be, because we cannot divide by 0. Now, you do not have to rewrite this back out. But I want to look at the restrictions for this one here at where we start here. So we know we can't divide by 0. We cannot have 0 in the bottom of the fraction. So if we look at the first fraction, we're mainly looking at the x minus 5. What will make x minus 5 be 0? Would be 5, because we can set x minus 5 equals 0, then solve by adding 5 to both sides, telling us x is 5. So if x is 5, we will have a denominator of 0. And if we look at the other denominator, we already have the x minus 5 covered, yes? So the x minus 6 would be 6. Because if we solve this here, x minus 6 is equal to 0. Add 6 to both sides. That'll tell us x is equal to 6, so that value does not work. Could x be 0? It actually can't. And the reason that it can't is it's coming into play. Erase that. This here. One more time. There we go. Is this here, this numerator x here. Because if we have x is 0, this number here, 0 times this entire thing is going to become 0. Over 0 minus 6 times 0 minus 5. 0 over 2 times 0 minus 5. If we plugged it back in, move out of the way here in a second, is what we get. But if 0 is in the numerator, what's the whole fraction become? 0, yes? Well, what operation are we using? We're dividing, yes? So if the numerator of the second becomes 0, the whole thing's 0, but we're now dividing by 0. So when we divide rational expressions and we're looking for restrictions, we have to look at the restrictions of the entire second rational expression, the numerator and denominator. We have to look at both. Now, we don't always have to go back to the beginning to figure it out, because we're looking at both. So even when we flipped it, it'd be better off to use this here. Scroll just here. Really, we could have just looked at this entire thing. Because top and bottom of it can't be 0, so it doesn't matter where it's at. Both of those, anything that would make the second fraction be 0, numerator or denominator after we factor it, is going to be a restriction. All right. Let's look at the next one. The first thing we can do is change it from division to multiplication and flip the second. So the first step with dividing rational expressions is to change it from division to multiplication and flip the second. Now we can go about factoring. Well, 11x is going to be 11x. 3x minus 9 has a greatest common factor of 3 that we can pull out of both. 3 factored out of 3x will leave us with x minus 3. 3 factored out of 9 is 3. Now we can pick between the x squared minus 8x plus 15 and x squared minus 5x, which one we'd want to do next. We can do the denominator because it has a greatest common factor of x. And if we factor x out of x squared, we're left with x minus 5. As we factor 5 out of 5x, we're left with 5. Now the last thing we need to factor is the numerator, our x squared minus 8x plus 15. Since the 15 is positive, the signs are the same and match the sign of the middle term, which is negative. So we have negative and negative. Factors of x squared are x and x. Now we need to look at the factors of 15, which are 1 and 15, 3 and 5. So we hope it is 3 and 5, because if it is, we do have something in common on top and bottom. The x minus 3s would match up, the x minus 5s would match up. And if we did check this, we would indeed get negative 8x. Questions on this so far? And again, we can multiply this together. And our like terms that we have are the x minus 3 and x minus 3. We also have x minus 5 and x minus 5. And lastly, we have the x's, which leaves us with 11 thirds. Or 3 and 2/3. Questions on this here? Let's go on and list the restrictions. For the first one, x minus 3 would be 3, because 3 minus 3 is 0. And we would have 5, because 3, x minus 5, 5 minus 5 is 0. And there's one more. Since we have this x by itself in the denominator, because x times something gives a 0, it's just going to be 0. So our 3 restrictions are 3, 5, and 0. Any questions on this here? They feel pretty good with these here. Yes? We're going to skip this one here and go on to number 45. Problem number 45. Now again, with any of these here, take it step by step, one step at a time. So the first thing we can do is change it from division to multiplication. So the first one stay the same, 4a squared minus 1 over a squared minus 4. And the second one's going to become a minus 2 over 2a minus 1. So the first thing we had to do was change from division to multiplication and flip the second. Now, out of these 4, 2 of them factor pretty nicely, and 2 of them are even nicer than that. Because if we look at a minus 2, is there a greatest common factor between a and 2? No. Besides 1, because 1 is a factor. And the degree is 1, so a minus 2 is as simple as it gets. 2a minus 1, there's not a greatest common factor. The degree is 1, so that is as simple as it gets. There's no way to factor it down any further than that. So that's kind of nice. Now, 4a squared minus 1. Because when we had 2 terms, it's either difference of perfect squares or sum or difference of perfect cubes. 4a squared, is it a perfect square? What times itself is 4? What times itself is a squared? A, because 2a. 2a times 2a would give us 4a squared, yes? Perfect square. Is 1 a perfect square? Yeah, 1 in. So this here would be 2a minus 1 and 2a plus 1, because our difference of perfect squares. A squared minus 4 is a squared minus 4 difference of perfect squares. So a squared would be a and a. 4 is a minus 2 and a plus 2. And we can put parentheses around the other one because we are going to multiply the numerators and multiply the denominators together. Now what simplifies out? A minus 2 and a minus 2. And 2a minus 1 and. In the numerator we're left with 2a plus 1 over. So I wanted to do this one to show you all that this is having a number left over is not all that we'll have. We won't just be left with 7/3 or 5/7 or some fractional number only. We can have variables left over too. It just works out the first two we did, simplified out almost completely. Any questions on this here? Now if we looked at the restrictions for this here, a cannot be. So for these here, a minus 2 would be 2. A plus 2 would be negative 2. And the only other one that we have is 2a minus 1. This one here might be a little harder to see right out, so we can go on and solve it. 2a minus 1 equals 0. So we can add 1 to both sides, telling us 2a is equal to 1. Divide by 2 tells us a is 1/2. So the other restriction would be positive 1/2. So if we have 1/2, positive 2, or negative 2, it would cause a division of 0, which does not work. Any other questions on this here? Do we want to look at 43 or 52? 52. Now 52, the first thing we'll want to do is change it from division to multiplication. So the first one, a cubed plus 4a, will stay the same, as well as the a squared minus 16, times. We flip the second one, so we'll have a squared plus a minus 20 over a squared plus 8a plus 15. Now, if we look at the numerator of our first one, a cubed plus 4a, is there a greatest common factor between a cubed and 4a? A. And we can factor it out. If I factor an a out of a cubed, we have a squared plus 4. And that's all we can do with that one there for now. Now, its denominator is a squared minus 16. A squared is a perfect square, and 16 is one as well. Because what multiplies together to be a squared? Well, a, and 16 would be 4 and. So we have this here. Any questions on what we've done so far? Now we can do the numerator or denominator of the second. It doesn't matter which one we'll do. We'll have to do both. So we can start with a squared plus a minus 20. Since the 20 is negative, our signs are opposite. One is going to be positive, one is going to be negative. The factors of a squared are a and a, because that's the only factor, so we'll go on and throw it in. Now we need to figure out the factors of 20. We have 1 and 20, 2 and 10, 4 and 5. Which one do we want to use? 4 and 5. Which one would be positive? 5, 4. And if we check this here, a times negative 4 is negative 4a. Positive 5 times positive a would be plus 5a, which will give us a positive a, which is the middle term that we wanted. Now the last one we need to factor is our a squared plus 8a plus 15. Since the 15 is positive, our signs are the same and match the sign of the middle term. So plus and plus. Our factors of a squared are going to be a and a. Now our factors of 15 are 1 and 15, or 3 and 5. So we can try 3 and 5 first, and it does work, because a times 5 is 5a, plus 3 times a is 3a, which does give us a positive 8a. And we can connect these here. We can multiply these here together. Now let's see what we have in common on top and bottom. We have an a minus 4 and a minus 4. We also have an a plus 5 and an a plus 5. Do we have anything else? Almost, but what's the one on top? A squared plus 4. Are those the same? And we actually can't factor a squared plus 4 because we don't have a sum of perfect squares. So it's as simplified as it gets. And since the a's have different values, we can't simplify that down. So the numerator is left as a times a squared plus 4. And the denominator is now a plus 4 times a plus 3. And that's it. Any questions over this here? How do we feel about this so far? Because for the most part, this is the exact same thing as what we did Friday, except for the first step. We're going to do one last one, and then I will give you the rest of the time to work on the assignment. So we look at this here. What is the denominator of our 3x squared plus 5x? It would be 1. Since there's not a denominator written, it's understood to be 1. So when you do our first step of dividing rational expressions, we change it from division to multiplication and flip it, our new numerator is 1. And the denominator will be our 3x squared plus 5x. Now we know 1 won't factor any further, so we can leave it there. And we can also leave 4x squared. Which one do we want to factor first? 6x squared plus x minus 15 or 3x squared plus 5x? So 3x squared plus 5x. We don't have a constant term, so it must have a greatest common factor, which is x. We can take an x out of 3x squared, which leaves us with 3x, plus 5. Because if we take an x away from 5x, we're just left with 5. We have this here. Now we are going to factor the numerator, the last one, 6x squared plus x minus 15. There's no greatest common factor, but since the third term is negative, our signs are opposite. One's going to be positive, one is going to be negative. Now the factors of the first term, 6x squared, we know we'll have x and x. Now the factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3, most likely. Because one of the denominators that we have is 3x plus 5, yes? So if we're going to have something in common, we're going to need 2 or 3 in front of x. Most likely we'll need a 3x, yes? Will the 3x be with the plus or the minus? B. Plus. Factors of 15. are 1 and 15, or 3 and 5. Since our 1 down here is 3x plus 5, we're going to hope that this here is the setup, because if it is, we will have something in common on top and bottom. Now, if we check this here, 3x times negative 3 is going to be negative 9x. 5 times 2x is going to be plus 10x, which does give us a middle term of x. Now we can multiply these together. All right, wake them up. Now, what's the only thing we do have in common on top and bottom? 3x plus 5 and 3x plus 5. So that simplifies out. That's the only thing we have in common on top and bottom. So we can multiply across. So we'll have 2x minus 3 times 1, which is just 2x minus 3. In the denominators, we have 4x squared times x. So we'll still have the 4x to the third, because x squared times x would be x cubed. So this here would be our final answer. Any questions on any of this here? And that